Have you ever seen research findings, perhaps an exciting new medical discovery or a machine learning model outperforming its predecessor, and heard the phrase, "The results are statistically significant"? It sounds like a definitive win, doesn't it? But what does that really mean, especially when we talk about something called a p-value? A low p-value, typically below a predefined significance level like 0.05, indicates that the observed data would be very unlikely if the null hypothesis were true. In simpler terms, it suggests that there is strong evidence against the null hypothesis, making us question its validity and perhaps favoring an alternative explanation for our observations. The why behind this lies in the very nature of hypothesis testing, which is a core concept in statistical inference. We start by assuming a null hypothesis, which usually states there is no effect, no difference, or no relationship between variables. Then we collect data and calculate a p-value. This p-value quantifies the probability of observing our data, or data even more extreme, purely by random chance, assuming that initial null hypothesis is actually correct. So, a low p-value means that observing our results by random luck alone is highly improbable under the null hypothesis, which leads us to doubt that null hypothesis. Understanding this core mechanism helps you avoid common pitfalls. For instance, a low p-value does not tell you the size or importance of an effect, nor does it prove that the alternative hypothesis is true. It simply quantifies the evidence against the null hypothesis based on your data. Therefore, to properly interpret a low p-value, always consider the context of your study, the sample size, and the magnitude of the observed effect. You should also be mindful of multiple testing, where conducting many tests can accidentally yield low p-values due to chance alone. One crucial insider detail is the distinction between statistical significance and practical significance. A study with a very large sample size might find a statistically significant result, meaning a low p-value, for an effect that is so tiny it holds no real-world importance. Conversely, a small but practically important effect might not yield a statistically significant p-value due to insufficient sample size. Therefore, always pair your p-value interpretation with a careful consideration of effect sizes, confidence intervals, and the subject matter context. Ultimately, a low p-value is a valuable piece of evidence, not a standalone verdict. It acts as a signal, prompting further investigation and deeper understanding of your data. By combining this statistical insight with a clear understanding of the experimental design, potential biases, and the practical implications of your findings, you can make more robust and meaningful conclusions in your research and machine learning endeavors.